Hello, my little mathematicians. Today, we're going to explore classifying rational numbers. And for the sake of sixth grade, that's all the type of numbers that exist. Okay, um, before we dive into that, I want to let you see that this is a Venn diagram. Okay, so everything that's in here is a part of this, and everything that's in here and here is a part of that circle. Okay, so you work your way inside out. This is, as you move further in, you get more and more and more specific. Okay, let's try and see how this works. So, all of these things are food, right? But let's try and get the most specific that we can get. So let's start with this inner circle right here. What is the only types of pie that you see? What would go in here in the pie circle? Apple pie would go in there. So let's write apple pie. Do you guys see any other types of pie? Yeah, pumpkin pie would go in there. Okay, anything else that can go in that inner circle? Nope, those are the only types of pie. So let's move out to that next outer ring right here. Okay, what's a type of dessert that isn't pie? Taco, brownie. Brownie's a type of dessert. Okay, so let's put that in this circle. I love brownies. Pizza, it feels like a dessert, but it's just food. Cake. Okay, cake is a type of dessert. Anything else? Nope. Okay, so those are the only types of desserts, right? That aren't apple pie. So now I'm going to go into food. All that's left are types of food, right? So let's go ahead and put taco in here. And pizza, it's a type of food. And corn, that's a type of food as well. Okay, now everything in all of these circles are food, right? Apple pie and pumpkin pie are food, brownie and cake are food, pizza, taco, corn are food. But I'm getting more and more specific as I go in. Dessert is a type of food that tastes delicious. And then apple pie is a specific type of food, and it's not only a specific type of food, it's a specific type of dessert because there's many types of desserts. So as you move in, you get further and further in, you get more and more specific. And then brownie is not a type of pie, right? But it is a type of food. Okay, again, brownie in here, it's not this, but it is a part of this. So this is a part of this circle and this circle and this circle. This one, the green one, is a part of dessert and a part of food. And then the pink writing is only within the food. It's not a dessert and it's not a pie. Okay, and that's how Venn diagrams work. We're going to use that same logic to classify rational numbers. Okay, so it makes most sense if we always start on the innermost ring, kind of like we did here. You know how we start with pi? So let's start with the most specific. The most specific ring is whole numbers. Whole numbers are the set of what we call counting numbers. And we call them counting numbers because think about it. When you start counting, you go 1, 2, 3, 4, etc. That's how you start counting, right? And then it's also 0. Normally people don't start with 0. Okay, but that is part of the whole numbers. Okay. Um, that's an example of whole numbers. So in here, I mean, we could put anything like 0, 1, 2, 3, 4. Is that it? No, no, no. It keeps going. 5, 6, like 100, whatever you want, as long as it's bigger than 0 and it's a whole number. Okay. And this next ring is what's called integers. Integers are the set of whole numbers. It includes those, but it also includes their opposites. So meaning, what's the opposite of 1? -1. What's the opposite of 2? -2. The opposite of 3 is -3. The opposite of 4 is -4, and so on. So like, remember how we said it goes all the way like 100, a million, a billion, a trillion? Well, you have -1,000,000, -1,000,000,000, -1,000,000,000. Okay, so it's all the whole numbers plus their opposites that are integers. So in this ring, I wouldn't put like 5, but I could put -5 because 5 would be a whole number, but as soon as I do their opposites, now it's an integer. Like 3 is a whole number, but -3 is an integer. Okay. And let's see, like negative or 100 is a whole number, but -100 would be an integer. And of course, those aren't it. Like there's so many integers, it's infinite. Okay. It's just any whole number or its opposite. But we put just the negatives in here that are the negative whole numbers because if it was a positive whole number, it would be part of the whole numbers group. Okay. The last one that we're going to learn about is called, oops, and you know what? I forgot to list some examples. So from here, like I know I included them in here, but don't forget integers also includes whole numbers too, right? Because whole numbers is within the integer circle. So you have, it starts like infinitely, like -3, -2, -1, 0, 1, 2, 3. Okay, and again, it keeps going. Now, is that all the types of numbers? No, because what about all the things in between? Like what's between 0 and 1? Half, 2/3, a fourth, 4/5. Fractions and decimals are between whole numbers, right? And there's also negative fractions and decimals. So rational numbers are all those numbers in between these guys. Plus, it also includes these because remember, rational numbers, integers and whole numbers are still within that circle. So rational numbers includes all of these, but it also includes any number that can be written as a fraction. And you're like, well, how is that the definition of a rational number? Because like it's not just fractions, it's all of these. Well, whole numbers can be written as fractions too, right? How do you write a fraction, or how do you write 3 as a fraction? 3/1, right? So it's any number that can be written as a fraction. So if we were to give the list of all the possibilities, obviously we can't. So we're going to put a dot, dot, dot because this isn't all of them. But let's say we started at -3, -2, -1. But it's also the things like in between there, right? So couldn't it have been like, let's say -1.5 before the -1? Or it could have been like -2/3 or something before I get to 0. And then before I go to 1, I can put like 1/4 or 4/5 or whatever fraction I want. Okay. And again, we said it's not also just fractions, it's also decimals, right? Because a decimal can be written as a fraction as long as it ends or it repeats. If it's a repeating decimal, you can write it as a fraction. Okay, so all of these are examples of rational numbers because they're either whole numbers or they're fractions or decimals or repeating decimals. Okay, so something that's not a whole number, not an integer, but it's a rational number would be if something has a fraction or if something is a decimal. And remember that they can be negative. Okay, there's such a thing as negative fractions. And or negative fractions or negative decimals. And it also can be repeating decimals. Those are rational as well. And there you go. For the sake of 6th grade, these are all the types of different classifications that work. Okay. They're all rational numbers. And then you can get more specific and say integers. It's whole numbers and their opposites. And then get even more specific. Now it's only including whole numbers 0, 1, 2, 3, 4, etc. All right, congratulations, my little mathematicians. You now know how to classify numbers.